Our speaker comes with 20 years of experience in software engineering, of which she has been carrying the responsibilities of Chief Security Officer for SIG for the last 10 years. She's regularly involved in specific client engagements with research objectives related to improvements within software engineering practices. That's Haiyun Xu for you. Miss Su will be joined by her team member, Mr. Thomas Kraus, who comes with 20 years of experience in the space of software engineering. Thomas currently works as technology lead and senior DevOps engineer at Software Improvement Group. Thomas has built his foundation knowledge through various consulting positions that has allowed him a broad view of the software development and operations world. In a few minutes from now, this dynamic duo is going to light up our screens with a talk on pragmatic risk management in the DevOps chain. With that, let's turn on the spotlight to our dynamic duo, Haiyun Xu and Thomas Kraus. Coming to your screens right now.
Hello, everyone. Today, we are glad to bring the talk Pragmatic Risk Management in the DevOps chain. We live nowadays in a world full of software systems. Software security is one of the most important topics for us. Although software practitioners took a huge effort on dealing with security issues in the past decades, we still hear news on security incidents, data leakages almost daily that are caused by vulnerable software. So today, we will present some outcome from our software research and share with our own DevOps team's practices and experience. We hope that our sharing can help more DevOps teams on managing these security challenges in a pragmatic way.
Hi, I'm Thomas Kraus. I work as technology lead and senior DevOps engineer at SIG.
I'm Haiyun Xu. I'm the Chief Security Officer and Platform Manager at SIG. So today, our talk is mainly divided into three parts. First, we will demonstrate the overwhelming software world and its security challenges. And next, we will present some of our software trends that we observed from our software engineering research. Finally, we will introduce our own DevOps practices and experience to bring some ideas on how to pragmatically cope with the security risks. So we are from the Software Improvement Group. At SIG, we engage in scientific research and software benchmarking and helps business and technology leaders drive their organizational objectives by fundamentally improve the health and security of their software applications. We believe that software assurance requires both outside-in and inside-out approaches. In order to fully understand the risk of a software system, it is not enough to only look at the software from the outside. You really need to look at the old code, the implementation part. Only then you will be able to reach a full understanding. So for the inside-out approach, with years of software measurement engagement, SIG built up a large benchmark data warehouse for software engineering research. So our data warehouse contains more than 50 million lines of code, spanning near 300 technologies. Based on this large data warehouse, SIG Research Department issues a recent software industry benchmark report, covering measurements across more than 7,500 software systems. One major observation is that there is a ticking time bomb of uncontrolled software supply chains. So let's take the Log4j vulnerability, one of the most known security issues in the recent years, as the example. As this vulnerability receives so much attention from the whole industry world, you might expect that all the DevOps teams have patched this vulnerability with the fastest speed. However, in reality, based on the Sonatype research, even today, 9 months after this vulnerability was made public, the vulnerable Log4j libraries are still being downloaded daily. So nowadays, software systems become more and more complex and overwhelming. The DevOps teams often find themselves drawn among the enormous amount of security issues and do not know where to start and how to deal with those. So today, we will share with you about the software trends we have observed from our research. We believe that these are important to guide us on what and how to cope with the security challenges. So first, as we just mentioned, that the log4j vulnerability story have already shown that outdated vulnerable libraries are still being used today. So we also take a look of the usage of overall open source libraries and how many days are the used libraries are outdated. So please note on this graph that in order to show the data clearly, we have taken a logarithmic scale on the x-axis. So on the labels, it shows 1 day, 14 days, 2 months, 1 year, and 5 years instead of a linear scale. So we observed that the data are concentrated in mainly 2 parts. The left part are the best ones. They are the leaders on patching open source libraries. So those libraries are upgraded quickly once new versions become available. However, this large amount data on the right bunch, that was the scary part. It's alarming. So these are the dependencies are outdated months to years. So this could be lack of knowledge, resources, or simply the team ignoring the risks. So also we need to be aware that the outdated libraries also often contain security vulnerabilities. So we see that the libraries are outdated. What factors can affect the speed of patching those libraries to address the vulnerabilities? So our research team shows that system build quality is one factor. So in this plot, we track the time to update for 3 groups of systems based on their build quality. So here, the quality measure we used here is based on the SIG maintainability model. So where we have the systems build quality that are benchmarked and rated with 1 to 5 stars. So 3-star systems indicates an industry average quality, while 2 stars means lower than the industry average quality, and 4 stars means above the average quality. So with our benchmark sites, the 2, 3, 4 stars this covers about 90% of the total systems. So this graph shows a clear distinction between the 3 groups of systems. It is clear indicates that the higher build quality system update their OSS libraries much faster. So this also confirms our intuition that better maintainable code is easier and more fun to update. So further, this also supports our general advice. So aim your system with 4 stars above the average quality, and this will help you to reduce the security risks from the outdated dependencies. So last, we would also like to show some more observations. So on the left side, we can see a clear indication that unmanaged dependencies are one cause of slow updating. On the right side, interesting enough, we noticed that the severity of vulnerabilities is not a major factor whether updates are done. This, of course, also reflected in the fact we just showed earlier. So many systems nowadays are still using the outdated and vulnerable log4j libraries that contain critical security vulnerabilities. Because of time, we cannot demonstrate all the trends we have found in our research, but we would like to share with you our 3 key messages out of our research. So overall, the enterprise software domain urgently needs to improve its OSS usage health. The OSS libraries of lower build quality have a higher risk of emerging security vulnerabilities. Client applications with higher build quality and automated dependency management are ahead of the pack. So based on our research and experience, SIG DevOps team also applies various best practices on dealing with the overwhelming security issues. We are glad to share our key practices and experience with you today. As we observed a shift-left trend on managing security issues, we first propose a structured approach to cope with the overwhelming security challenges. As a fundamental part, we need a defined software security evaluation model. Based on the model, we can define the KPIs to measure the different security aspects. Further, we aggregate the measurements to ratings, which enables the comparison among the different security software systems for benchmarking. So finally, of course, our goal is to improve security. So all these previous steps enable the team to identify the potential improvements and also prioritize them. So this is highlights the steps of our structured approach. Next, I will give some concrete examples on the measurement and aggregation steps. So as we talked earlier, so our software system contains both our own code and third-party libraries, and both may contain vulnerabilities. So we need to using some tools to bring this transparency. So there are many security tools that are available in the market on code security analysis. So these tools will provide the list of vulnerabilities. In general, the tools are able to indicate the severity of those vulnerability findings or report the CVSS score, which reflects the severity of the CVEs, the vulnerability in the OSS. So by quantifying all the reported vulnerability with a consistent severity, this allows us to aggregate and prioritize the vulnerabilities from different sources. So from the daily development practices, a team can encounter hundreds to thousands of vulnerabilities among their software systems. So should the team deal with all of those vulnerabilities with the same speed? Answer is no. So based on our advice is we designate an evaluation model for remediation guidelines on resolution timelines based on the vulnerability severity. So in this table, we show the risk category. So this risk category summarizes, so for different type of severity vulnerabilities, the team should deal with them also differently. So the risk categories showing here with low, moderate, high, very high, also indicate that if a team fail to patch a high severity vulnerability within a reasonable timeline, so the software system also will expose to a high risk. So after presenting our research findings and theoretical approach, I will now give the floor to Thomas, who will further share our DevOps team's practices and experience on managing security challenges.
Yes, thank you, Haiyun. Modern software development that meets all non-functional expectations starts with awareness, understanding how and where things can go wrong. We, of course, listen to our research departments and embed their findings in our way of working. And we expect tomorrow's risks. We realize that there are more vulnerabilities present in software today than the ones that have been identified. So our development team should be able to address those risks once they get identified. Secure coding is something that actually requires training. Which constructs to use or to avoid is something to learn and to practice. Guidelines and peer reviews help here. Development process, it is helpful to have guidelines documented because often there are multiple approaches to addressing a certain challenge. And it's useful if a team can deal with those similar challenges in a consistent way. For example, our development process is described in a brief high-level document, about 2 pages, where we talk about the ticketing system that we use, the issue tracker, version control, automated testing, and these things that hold for all software development that we do. Then in more specific places, for example, for a specific system, we can have more detailed documents. For example, an architecture decision record, which documents in a concise way trade-offs and consequences of a decision that we made. We are a fan of peer reviewing code is not only to supervise junior developers, even the most senior team member can make a mistake or just not think of a simpler and therefore typically more reliable and secure solution. So two people just see more than one. More tooling also becomes available to support peer reviews, but for the moment, we don't completely leave this to automated tools just yet. The human review still adds value. We allow structural time to address tomorrow's risks. So that means that our sprints, our iterations are not filled only with functional features, but we also allow the developers to work on reducing technical debt, decommissioning older and obsolete systems. And in doing this, we don't strive for perfection. That typically does not have the best return on investment, but we do enough to allow efficient maintenance in the future. And we measure this. We also report violations. So when the team fails to remediate vulnerability or address a risk within the specified time frame, even if it's a low risk, the team will report this to our security department, just in order to be able to look back and spot any trends. And when this happens more often, possible root causes can be discussed and addressed. In the tooling that we use in the development process, we can, of course, use a lot of tooling in our continuous integration pipelines, where the tooling gets used and applied after every commit. But we also make a trade-off between the value of scanning the entire code branch each and every time versus the total duration of the CI pipeline. Certain tools simply take too long, and therefore it's better to schedule them daily or even weekly. Finally, it's not only about the software that we write ourselves and libraries that the software uses. It is also about system packages that you may find in your Docker images or on Linux servers. So we also scan for these and patch whenever vulnerabilities are being reported in those. Beware, in Docker images, there may not always be a newer version of a third-party base image once a vulnerability is being reported. So sometimes you have to assess how to deal with such a case. Of course, this is how we work based on the set of tools that we use in our process. We encourage you to map and translate these practices to what best fits your team. Risk strategies. There are a number of ways to deal with risks or reported vulnerabilities. And we think it's a good practice to have an explicitly documented risk treatment plan for certain risks that are reported. The development team can choose between mitigating the risk, which means, for example, upgrading a library in which a vulnerability was reported, or refactoring code. And this is applicable in many cases, in most cases. But the team can also choose to avoid the risk altogether by, for example, this is something that we also do, let's say, in the background as a continuous process by decommissioning older systems in order to reduce the attack surface. And we can also review the actual necessity of certain libraries. It happens occasionally that your software system depends on a library, but actually only uses a very small portion of the functionality of that library. In such case, you might make the trade-off to remove that library and have the little bit of functionality as custom code. When mitigation or avoidance of a risk is not a feasible option, or at least not within the time frame that you have in your guidelines, it may also be an option for the team to accept the risk. This, of course, does require investigation to know that you may not actually be vulnerable. You just don't want the risk to be reported every day again. But this is something that should be used on exceptional cases only. Finally, there's a fourth way of dealing with risks. This is something that you don't decide on a case-by-case basis, but it's a bit more of a structural decision. You may transfer risk to another party by, for example, taking a cyber insurance or outsourcing your infrastructure to a public cloud provider, or even outsourcing software development itself. The latter we do not do at SIG. Of course, if you have such a development process, it's very important to make sure that it's a sustainable process, that it does not deteriorate over time. So we find that it helps to introduce some fun factors in the process and in the way of working, so that colleagues are encouraged to keep up with the good practices. We also find it's very nice to celebrate successes. One example of a fun factor is a chatbot that we created. This connects to Sigrid, our software assurance platform, periodically to retrieve vulnerability information. And if there's anything to report, it will do so in the chat, so that colleagues can immediately see this, react to it. And another feature of the chatbot is that it also congratulates the team if a number of days in a row, no new vulnerabilities were reported. Then, in summary, the structured approach, as shown by Haiyun, can be applied to other quality aspects as well, such as reliability, performance, etc. This is also something that we do at SIG. Some takeaway message of this talk. When you return to work, we encourage you to do a quick check to see whether your team is doing the necessary things. Do you see all the risks reported by the various tools in one place so you can prioritize? Are your expected risk resolution times based on criticality? And is this documented explicitly? Can your team structurally work on non-functionals? And is there a procedural way out if a risk cannot be solved, or you don't want to solve the risk because you considered it to be of such a low risk or not actually applicable to your real situation at all? If you're not doing these things in your team, then check the trends that we discussed today, if those are hampering you, and consider why that is. And of course, don't forget to review the fun factors in your team. It's also nice to introduce something new, to make colleagues enthusiastic about keeping up those good practices. Finally, feel free to download our recent benchmark reports to read more details for yourself. This concludes our talk. We hope that these 4 easy steps help you manage security challenges in a pragmatic manner. Thank you very much.